So I'll just give you points to the next slide and whatnot. Yeah, so everybody's able to read slides, so I'm not gonna like talk over slides. I'm just gonna give some highlights. So Apache Spark, yeah, originally compiled with 2.11, before version 2.4. Then they decided to start releasing 2.12 variants, and these carried on until about 3.2, at which stage they were like, okay, fine, we're going to produce 2.12 variants and 2.13 variants. Right now, they still produce 2.12 and 2.13 variants. So those of you that have ever worked with Scala know its infamous binary incompatibility problem between major versions. So like 2.11 cannot work with binaries compiled with 2.12 or 2.13, etc. And the reverse is also true. There's no sense of backwards compatibility either. It's basically you compile code with 2.11 and you need other binaries that were compiled with 2.11 if you want your code to carry on running. Now, this for someone writing Java, this isn't really a problem because we don't care about Scala's binary compatibility. We just like give me the code, give me the type signatures, and I can work with it. However, as you're soon to find out, can you go to the next slide? There was the Scala language maintainers did something with 2.13, right? And this was specifically, they made a change to the collections API. So this isn't a binary compatibility problem. This is a type change problem, right? So in Scala 2.12, they had a type called a sequence, right? Or SEQ for short, but I will carry on saying sequence. And its full name was scala.collection.sequence. In Scala 2.13, they changed this name. Well, more specifically, what they did is when a Scala developer writes the word sequence in their code, the Scala compiler would insert scala.collection.sequence in 2.12 and earlier versions. When it came to 2.13, the sequence was essentially changed to reflect as Scala collection.immutable.sequence. Now, this is a problem mostly around method signatures in the JVM, right? Because the JVM needs to know the identity of a method, and an identity of a method is given by the return type, the name, and then the input types, right? So if one of these things doesn't match and it cannot find it, the JVM throws the infamous no such method error, right? Which will just, for all intents and purposes, tear down your application as what happened to us when we were like, yo, we've got OpenLineage Spark, let's go. And our sister teams didn't tell us Scala 2.13 that they're using, or they're using Scala 2.13 variants of Apache Spark. And so, yeah, we were scrambling there, trying to understand what actually happened. Next slide. So this is just some code snippets of simplified code snippets, right? So in the top, you see trait something with def data sequence int, right? So that's Scala, right? This is what a Scala developer sees. This is what they write. When the Scala compiler runs, right, it generates something that looks on the right. This is a general simplification because there are other things that, for all intents and purposes, we don't need to get into, right? But you can see it puts the fully qualified type name as the return type there. So scala.collection.sequence. Note, this is for Scala 2.12 or earlier. Now, we can use this compiled code right in Java, which is the snippet at the bottom, right? And we're quite happy to consume it. It's a bit awkward for a Java developer to consume Scala code, but hey, we can live with it. Next slide, please. Right, so now comes Scala 2.13, and the Scala compiler does the same thing, except if you contrast the bit on the right with the previous slide, you'll notice that there is a slight change in the type signature. Namely, it's now scala.collection.immutable sequence. Recall, the JVM uses three things to identify a method: the name, the return type, and the input types. The fact that this return type has changed in the eyes of the JVM, but not necessarily the eyes of the programmer, right, means we will get a no such method error. Right, next slide. And so you have this Java code. it expects something on the left, but it's now getting something on the right. And this is what causes that no such method error. So next slide. So how do we go about solving this? Well, it's a complex problem, first and foremost, right? And the complexity has to live somewhere. There was a lot of back and forth, particularly in my own mind, of which approach I should take. But I tend to value compile time safety over anything else. And for this reason, I chose to go down the route of moving the complexity to the build system. Right. What this meant is I mostly didn't need to touch any code. Right. There were some places where we did have to touch code, specifically when it came to the conversions from a Scala collection to a Java collection. But for all intents and purposes, the code remained largely the same. The only difference is now the CI/CD process had to be expanded to include 2.13 variants. The publishing process had to be expanded to include 2.13 variants, and the entire Gradle build mechanism had to be able to handle this switching, right? And this is controlled via parameters that are supplied at runtime. Other options were using so-called reflection. Reflection is all good and nice, really easy to use. However, it is notoriously slow. When I say notoriously slow, I'm talking in orders of magnitude slower than regular Java code. And in a tight loop, this can be a significant performance detriment. It also means that you don't have compile time safety anymore. You now need to write unit tests to validate that what you wrote is actually going to run correctly. Java, I believe 7, maybe Java 8, introduced the concept of method handles. Method handles are a really nice way of writing reflection code, or sort of reflection code, but it's more strongly typed than regular reflection. It's also significantly quicker in terms of its runtime. It's almost as fast as writing or using regular code. The downside there again is it's still runtime checking based, right? I still have to write unit tests to be able to do this. Another option which I immediately dismissed when I thought of it was bytecode weaving. This is when you get the Java compiler to compile your code, and then you go and inspect the bytecode afterward and manipulate it there. That requires expertise on all the bytecode operations, and you have to be aware of it. It's almost like assembly language in that it's a stack-based thing. So you need to know the order of operations that you need to put things in. Otherwise, you will experience wonderful runtime errors that would probably like throw you for a loop, and you'd be really confused. Next slide. Right. So the result. Well, as I said, we published. We now have support for Scala 2.12 and 2.13. This necessitated us having to publish 2 artifacts, right? And there's a little picture at the bottom there that shows, hey, on Maven repository, we now have a Scala 2.12 and Scala 2.13 variant of the OpenLineage Spark integration. And that's pretty much it, right? Like it was quite a long lead up as we had to go through a process of modifying each individual module within the Spark integration to say, examine, does the thing support Scala 2.13 or not? And if it does, well, we need you to compile against the Scala 2.12 binaries and the Scala 2.13 binaries simultaneously. Well, sort of simultaneously, obviously just in different build processes, but that capability had to be inserted into the build process. Yeah, that's it for me.